Okay, hi everyone. Thank you for coming out to the Bay Area Paragliding Weather Tools Clinic. The goals of today's clinic are to learn about the climate and common weather patterns in the Bay Area in Northern California. We want to learn about the tools, websites, and data that are available and how to use them. And finally, the last goal, and arguably the most important one, is to be able to independently make informed decisions about which sites to fly in a given day based on all available data. Sure. You could. Okay, so I guess first I should probably introduce myself. So my name is Evan, and I'm here. Well, I'm going to tell you why you should listen to me and maybe why you shouldn't on some occasions, but basically, I have been interested in and arguably obsessed with clouds since I was very young. My parents are sitting in the room and can attest to that. So when did I start paragliding and when did I become interested in wind sports? So I actually started out flying paramotors and snow kiting in 2008, which is like 9 years ago. Then the next year I started free flying, I ditched the motor, and I also started kiteboarding. 2 years later, I moved to the Bay Area, so that was 2011, about 6 years ago. I started hydrofoiling or foiling last year in 2016, which is another discipline of kiteboarding. And basically, I am obsessed with weather. I watch the weather conditions every single day like a hawk from my office window, which now has a perfect, horrible view of Mission. It's just, it's torture. I think I've had some reasonable success in going across country in the Bay Area sites proper, so Mission and Deerfield, namely, and Windy Hill. And yeah, that's basically my background. And next, I will let Honza introduce himself, but he barely needs an introduction. Over to you, Honza. Go ahead.
Okay. So I started flying 25 years ago. First tried it in Quebec. And then I learned at Airtime in the Bay Area. Ended up teaching there for a while. Ended up doing many seasons of tandem paragliding in Idaho, in Sun Valley, Idaho. And had the privilege of representing in 5 x-alps. And also been, just really into weather, so I ended up getting a master's in atmospheric science and been writing articles for the last 10 years for cross-country magazines. And I'm happy to be helping Evan out with this clinic.
Thank you. Okay.
You're welcome.
Yeah, that's it. Quick summary of the agenda. So we're going to start off talking about the climate of the Bay Area and of Northern California, and also talk about the seasons that we have here. I think people will often say that there's only 2 seasons in Northern California, the wet and the dry season. There are sort of 4, but it's a bit of a blurry transition. Then we're going to go into the tools discussion, which is really the main focus of this clinic. So there's a list of all the tools here. I'll go through these one by one. And then finally, to end off the clinic, I'm going to show some examples of some fairly recent good cross-country flights that I've had in the Bay Area, and also correlate those with the forecast from the day prior or even 2 days prior, and show some examples of soundings from the day after, or from the same day at the end of the day, just to try to match up what the forecast was before and how that translated into a good flying day. And then at the end, we'll do some Q&A. So the first part, climate of the Bay Area. It's important to understand the topography of Northern California in general. So this is a very zoomed out view. You can see you have parallel coast ranges basically stretching from the north end of the Central Valley all the way to the south. The interesting thing to note here is that the prevailing winds out over the ocean in this area generally parallel the coastline. So the winds out over the ocean generally blow from northwest to southeast. And there's this interesting phenomenon, which I'm not going to go into too much detail here about, but it's called Ekman transport. And basically, we already have this very cold water just off of the coast of California that makes its way down all the way from Alaska. But the water cools even further because what happens is you get this weak surface current which blows very slightly offshore. which causes upwelling, which forces very cold water from the depths of the ocean to come up and basically cool right off of the coast of California. So you have this this interesting topography where you have very cold water, very hot temperatures inland, and these parallel mountain ranges, which mostly block the marine air from filtering in, with the exception of these big coastal gaps that we have, like in the Bay Area. So zooming in.
Hey, Evan, this is Honza.
Go ahead.
Can you hear me? I was just going to mention on that while you're talking about the upwelling, that's part of the reason why it's often foggy in the Bay Area and Monterey, as the air has come over the Pacific, and then it's fairly close to dew point just because it's over a source of water, and then it gets over a colder surface. This upwelled water is, it's even more likely to have stratus or fog right near the coast than out at sea due to that extra cold upwelled water right by the coast.
Yeah, and that's actually a really good segue into the next picture and the one after that. So what happens is, namely in the summer, a little bit in fall and spring, and less so in winter, we actually get an extra, not really an extra, but there's a distinct layer of the atmosphere that forms directly over the ocean called the marine layer. And very interestingly, it's typically of a depth of around anywhere from 800 to 1,800 feet, sometimes more, sometimes less, but that's roughly what it is in the summer. And if you think about the height of the mountains in the Bay Area, I mean, think of Mission and Ed Levin and Windy Hill and just all the local peaks that we have here. It's roughly around 2,000 feet plus or minus. So that makes for some very interesting interactions. We have this layer of air sitting just off of the coast and penetrating slightly inland. And it has a way of creating very complex wind patterns that funnel through the Golden Gate for one, a little bit south of that, like near SFO and San Bruno. And it gives you all kinds of interesting daily breezes like the Delta breeze and the strong north winds that blow down the bay. So we have this very interesting and complex topography and marine inversions and all kinds of little microclimates that happen in the bay. And that can make it particularly tricky to forecast good flying days, but there are ways to do it.
And Evan, I was gonna add, on the coast, the depth of the marine layer is often, as you drive, for example, from Santa Cruz to San Francisco along the coast, you notice there's areas where the sea air can come in, and some places where it's totally blocked. It can be white capped, and you drive a few miles down, and it's totally blocked off just because the mountains are a little bit higher. They block the marine layer, and it can't make it inland. So just driving down the one, you get quite a bit of variety to where where marine air can come inland or not.
Yeah, so that kind of leads us into the different seasons that we have in the Bay Area, and I figured I would start off with summer. Let's go from worst to best as it pertains to flying in the Bay Area locally. So summer, what characterizes summer in the Bay Area are temperature inversions, and as I mentioned before, typically the inversion in the Bay and on the coast is somewhere between 800 and 1,800 feet, plus or minus. What really defines the climate of the Bay Area is the microclimates in the summer. So you have a foggy, cool coast, you have hot, dry, and generally breezy conditions inland, and you have this daily pattern of wind that comes in. So it often starts us sort of calm in the morning, and then by the mid to late afternoon, you have this north wind that comes down the bay, and then you have the delta breeze that picks up in the Sacramento Delta. And it's largely caused by the presence of what's called the North Pacific High, which is this high pressure system which kind of parks itself just off the coast of the west coast of North America. And it generally makes things really stable. So, I mean, with stable air, it's sort of, you have this cold air below, which kind of funnels in through the coastal gaps, and you have this hot air inland, cold air below, warm air above. It doesn't really mix. It's generally pretty stable. The one exception to that is sometimes the pressure will drop over the summer if you have a trough, or I guess, I don't want to go too much into that, but basically the pressure will occasionally drop in the summer. What happens under those conditions is the marine layer will actually deepen, sometimes fairly significantly, up to 3,000, sometimes even 4,000 feet. And that can actually make for some good and very interesting soaring conditions in the summer, but it doesn't happen too often. Okay, so I guess the summary of summer is you have consistent flying conditions, but often mediocre. Your best bet is to head to the bigger mountains inland where there's more instability and probably a better chance of getting some good flights in. Okay, so then the next season, autumn, which is where we are right now, the marine influence starts to weaken. So generally what happens is the pressure gradient kind of stabilizes. You don't have those deep marine intrusions like you had in the middle of summer. And we also start to get storms dropping down that form in the Gulf of Alaska, like way up north. And it's very interesting because today, actually, right this second, we have the second, somewhere between the first and second of these Alaskan lows, which is coming right over us right now. We can talk about that later. Of course, it's the transition between the dry and the wet seasons. We're more likely to get rain. The, I guess, downside is that days are shorter. There's less sun, less ground heating. So that's one negative factor. It's also it can tend to get pretty windy in autumn depending on the conditions. There are these types of systems called inside sliders, which is basically a low pressure system which migrates inland into the North American continent, but it kind of drops down on the east side of the Rockies. So if you think about a low pressure system, how it circulates, it's counterclockwise on the west side of the low, which if it's over the Rockies, that's kind of near the Sierra, maybe somewhere in the Central Valley. You get this strong northerly flow, and often you get high pressure building in behind it. So what happens is you get these really strong north winds, which incidentally was a large contributing factor to the recent fires up in the North Bay. And also, it's also what leads to Santa Ana winds. But what also happens is, given the right mix of conditions, if it's not too windy, if you have some cold air that has filtered in, you can have some really excellent flying days in the Bay Area in fall. My personal best flight ever in the Bay Area happened, I think it was September 22nd, and I'll talk about that flight later. But this is roughly the time of year when you can have some really good flights. You just have to pick your days wisely. The next season is winter. So there is typically a weak or no marine inversion at all, because we generally have colder air that's filtered in from the north. And remember, what causes the inversion is you have this cold air that's sort of pooling over the Pacific. In the warmer seasons, you have warm air that's inland and it stabilizes. But if you get rid of that warm air and cool it down, the air or the atmosphere in the Bay Area is less likely to be inverted. The downside is that it can often be rainy and unflyable. I mean, last year is a good example of that. The sun is obviously its weakest in the winter, so we have less heating on the ground, and that it just makes it a little bit harder for the ground to heat up to cause convection. But very interestingly, if you get a really cold system dropping down where just a couple of thousand feet above the ground, even like maybe 2,000 feet, it can drop to freezing or below. Those can bring some excellent flying days. Go to Mount Tam on those days if the winds are going to be light. So I guess the summary of winter is that there are sporadic, but some excellent flying days to be had, particularly later in the season as we start to get a little bit stronger sun.
So I was gonna add to that. Basically, if you're freezing at 2,000 or 3,000 feet, then your ocean, which is in the in the 50s or maybe low 60s, or it's a source of warmth. Suddenly, that is what seems to us as a cold ocean now is a really warm surface for that air, and that's seen beautifully in this picture that you see. Convection even out over the ocean. There's a little bit of convection because the ocean surface is just warm compared to how cold the air is above it.
Yeah, that's right. And that brings us to the last and arguably the best season for flying in the Bay Area, which is spring. So we generally have a fairly strong lapse rate, and lapse rate is it's the rate at which the atmosphere cools as you rise. So generally we have better solar insolation. The sun is a little higher in the sky. It heats the ground. We still have this pool of cold air lingering from the cooler months. The marine inversion is likely to become present as you get later in the spring. So mid-May beginning of June. I guess it seems that late March, early April, and sometimes days in May are when the highest likelihood of having good flying days are to be had. And the other nice thing is that, assuming it was a wet winter, there's a fair amount of moisture trapped in the ground. We seem to be fairly cloud deficient a lot of days in the bay, particularly in summer. But once there's a lot of moisture that's made its way into the ground over the wetter months, we can actually get some really nice cloud flying days, particularly in early spring. So I think in general, there are fairly frequent good flying days, and often the best days of the season are in spring for us. So in summary, just to characterize the seasons, actually I'm going to turn this one over to Honza, but basically there are three general scenarios that you want to look for in any forecast, regardless of the season, that tend to make the Bay Area work for good flying. So over to Honza for this one.
Yeah, and I don't actually, we put this slide in later, so I don't have it in front of me, but and to have good soaring conditions, I'm not talking like ridge soaring, I'm talking thermal soaring. You need a deep enough layer where the air from the ground on up is just dropping off at the dry adiabatic lapse rate. It's cooling with height at 5.5 degrees per 1,000 feet. And so within a marine layer, you might have that, but it could be too shallow to be too useful. But if the marine layer gets deep, like if a little bit of a low pressure moves over and deepens the marine layer, then it can be within the marine layer. The other one, as we talked about in the wintertime or springtime, when air is cold enough to where even the ocean is a source of warmth, temperature continues dropping with height. There is no real marine layer at that point, and you can have just a great lapse rate, and those are the days where you can get to 5,000 feet at Mount Tam on the magical day. And then lastly is an interesting feature when you have offshore flow, sometimes very strong offshore flow. I remember a day in Mount Tam in particular where I drove up there and the branches on the road, there's a lot of broken pine branches, and it'd been very windy the night before. And then that offshore flow just eased, and the wind basically was non-existent, just starting to come in onshore, but it's pushed a marine layer way out to sea with strong winds, and now you've got land air in the coastal regions, and that land air can have a really good environmental lapse rate again, where it's dropping off at 5.5 degrees per 1,000 feet for quite some height. And so any one of those three can make for some really nice thermal flying, even though we're really close to the coast.
Cool. So that's a good segue into the tools discussion, which is the main part of this lecture here. Actually, just before the tools, I want to go over a quick slide on units and conversions. But basically, the tools will help you identify those three scenarios that Honza just mentioned that give us good flying conditions. But just before getting to the tools, one little tidbit on units and conversions. So the first tool that we'll talk about in a minute is the forecast discussion. But there's also soundings, sensors, and a number of different tools that we'll look at. We live in the United States, which uses the imperial system, unfortunately. But basically, when you're using these different tools, you will get a combination of elevation in feet, elevation in meters, wind speed in knots, miles per hour, kilometers per hour, just a whole hodgepodge of different units. You don't need to memorize all of the conversions to the exact value. Just go to Google, say like how many meters are there in, or like what is 1 foot in meters or something like that. And Google will do all the conversions. But when you're reading through these forecast discussions and using different tools, it's good to have some very quick conversions in your head. And I'm not going to read this slide word for word, but basically this is just a very quick reference guide that you can use. So just a couple of them, like 60 Fahrenheit is 16, 20 Celsius is around 70 or so. For speed in particular, this is actually an easy one to remember. The very last line is an approximation. 1 knot is pretty close to 1 mile per hour, which is pretty close to 2 kilometers per hour, which is pretty close to a half a meter per second. So yeah, kind of a fairly easy one to remember. The other one for atmospheric soundings in particular, which, as I mentioned before, we're not going to spend too much time on just because could spend an entire lecture on that. But there are, we talk about altitude in terms of meters, feet, and also pressure altitude, or density. Yeah, pressure altitude is the right term. So basically, often when you're looking at a sounding, instead of seeing how many feet or meters above the ground, you'll actually see what the standard atmospheric pressure is at that particular altitude. And this guide here can show you some rough conversions between the two. One that you really should memorize is a constant, which is the dry adiabatic lapse rate, which is generally, it's the amount that the atmosphere cools in order to have useful convection for flying. That's probably the easiest way to think about it. It's a fairly easy one to remember. It's 10 degrees per 1,000 meters or 3 degrees Celsius per 1,000 feet. So that's, if there's anything that you're going to memorize, it should be the one on the bottom right there.
And I was going to say one thing there. If you're getting temperature off stations, like if you're looking at how cold it is at the bottom and how cold it is at the top, sometimes it might not be quite the full dry adiabatic lapse rate, and it can already start to be good for thermals because surface temperatures don't decrease as quick as the ambient air around them because the surface just, is getting a lot of sun. So, if you're getting a reading off of the station that's 2,000 feet higher and one that's 2,000 feet lower, if it's not a full 11 degrees colder up top, it doesn't mean thermals aren't turning on. It's just surface temperature sometimes might have less of a difference, even though it's already good for thermals.
And this one is for Honza also, I guess, another precursor to the weather tools. So I'll just give a very quick intro here, but basically all the tools that we use, whether it's forecast discussions, which are basically a human looking at these models, which we're going to discuss here, and namely XC Skies and Windy, all of the data is based on 2 global weather models. So I'll turn it over to Honza again, but it's, again, we're not going to go into too much detail here. It's just good to understand how the data for all these different tools gets assembled and then how it gets displayed.
Okay, so I'll try not to be too long-winded on this, but basically a weather model is it uses equations to step forward in time, basically fluid dynamic equations. So you need to know what the atmosphere looks like, and that's why we send up soundings, we have satellites, we have ground stations, and we get the best sort of current status. And that's blended with a prior forecast from either 6 or 12 hours ago. And that initializes the new round of forecasts that go out maybe 10 days into the future at certain increments. But then you've got, as Evan mentioned, 2 global models that cover the whole Earth. That's the GFS, and that one there's many links to GFS data. And then there's the ECMWF, which is the European model, and they're much they about their output. Fortunately, in Windy, the creator of Windy is paying for that at a very hefty $250,000 a year fee to make that available to the public. So otherwise, it has to be like a forecast office that would have it, or a research institution. So the ECMWF model is a smaller grid, which makes it higher resolution. It's on a 9-kilometer grid, whereas the GFS is on a 22-kilometer grid. And in a model, you need about 4 grid boxes to resolve a feature. So to the model, even to ECMWF, it doesn't see Mount Diablo. It doesn't see the details of the bay. These are just undulation, very smoothed out undulations. Then there's more regional models that feed off one of those. For the ones over us, like the NAM or the even one other higher resolution model, will use the border conditions from GFS and then downscale it, and so you get a little more resolution of the terrain features. But still, many things like ridgetop compression, channeling through valleys, even seeing these valleys, that the model doesn't see that. So you basically have to learn to take model output for your area and then see what that means. You almost have to like create when the model said this, it actually meant this at this spot. It's kind of like model output statistics. You got to create this picture for your flying site or your spot. What does this, model guidance mean? And then lastly, when there's, usually when these models are in agreement, that gives you a little more confidence. When models diverge and then there's not much confidence. So, if you're just using weather.com and you're looking out into the future, a 10-day forecast, I would rarely trust that unless it's in the summer on the coast or something where it's just always going to be the same weather. So we'll talk about the forecast discussions, because there's people looking at these models 8 hours a day and then writing up a summary of that, and that's really useful.
Cool. So that takes us into the area forecast discussions. So the forecast discussions, they are typically published anywhere from 2 to 4 times daily by each National Weather Service office. And typically when you read a forecast discussion, it'll discuss the short-term, long-term, marine forecast if it's a station that's close to the coast, aviation weather, and depending on the time of year and the local conditions, sometimes you'll get fire weather, snow forecasts based on all of the data from GFS, ECMWF, NAM, like basically all the models. And it's, again, this is a professional trained meteorologist looking at all this data and giving a verbal human description of what is going on. And often what you'll see is the forecaster will mention the forecast confidence. So he or she will say that this model says this and that model also agrees, but this one differs slightly. So you can kind of build a picture of how confident a particular forecast is on a particular day. Some of the terms can be a little bit challenging to follow, but there's some key phrases and patterns that are worth cluing into, and I've highlighted a couple of them on the next page. The nice thing is most of the terms are defined and are hyperlinked. So if you're reading a forecast discussion and there's some crazy acronym that you don't understand, just click on it and it will often describe what it is. Sometimes the descriptions are not so great, but you can piece it together. So in the bay, often some things to look for are the marine layer depth, stratus intrusion. That means that the marine air is kind of filtered in and things might be getting stable. Onshore flow, offshore flow, delta breeze in particular. That's the wind that blows just north of Mount Diablo. Cirrus clouds are often mentioned, and as I'm sure you know, those can shut down flying for us. Instability and cold air advection is a nice one. That means that there's cold air blowing in from somewhere else, and that's likely to make things unstable. For the Bay Area and Northern California in general, probably the most useful one is the Monterey discussion, or the Monterey office, which covers pretty much all the Bay Area sites. Sacramento is useful too, particularly for Diablo, just because Diablo kind of borders on the Central Valley, so it is kind of interesting to know what's happening in the Central Valley just from the forecast discussion perspective. If you're going to Dunlap or Toll House, you can read the Central Valley discussion from the Hanford office. And here's a bunch of other ones. There's Reno, Eureka, Medford. Basically, you can just Google to see where all the forecast discussion offices, or where all the weather service offices are. The easiest way, don't even bother bookmarking anything. Go to Google and type in AFD, which stands for Area Forecast Discussion, National Weather Service, and then the city. And usually the first or second link will take you to a forecast discussion for that area. So this is the first tool that I always go to when I'm trying to figure out where to fly. Like I don't even bring up XC Skies or Windy. I'll just read the forecast discussion, see what somebody else has already pieced together, and then kind of make my own assessment after that. Okay, so the next tool, which I'm sure many of you have heard of, is called XC Skies. This is a paid subscription tool. I can't remember the cost. I think it's $40 a year. But this is particularly useful for browsing through different forecast parameters. Winds aloft are useful, surfaced winds. Top of lift is arguably the most useful. That'll tell you how high you're going to get in a particular day. You can figure out where cloud base is, how much cloud cover there is, so if there are cirrus clouds that are coming in. temperature, and instability. So again, going back to what Honza talked about before, there are different models that are available. And the nice thing is that with the click of a button, you can toggle through the model output for each one of these and see how it differs. So basically zoom in on a particular area, click on one model, click on the next model, and see if the top of lift or if the wind's at the surface or the wind's loft, see if there's agreement between all of those. There's this feature in there called the point forecast, which is useful for looking at many of the above parameters for a specific spot all in one view. So you can click on a point in the map and it'll show you the top of lift, it'll show you winds at different altitudes. I find personally that it's actually not particularly useful for the Bay Area proper. And I think for a reason that Honza mentioned before, the grid size won't even resolve the features that we have in the Bay. So if you were to click on a point on the map, like let's say you were to click on Diablo, you may as well click anywhere within a 22 square kilometer grid, and it would probably be somewhat of the same data. So I generally like to use the map view because it just gives you a broad picture, and just using local knowledge combined with the general winds and instability in the area, you can build more of a mental model as to what's happening in the area. The models that XC-Skies relies upon are GFS and the NAM 12 kilometer, as well as the NAM 3 kilometer and the HRRR, which stands for high resolution, and the RAP. I kind of skipped ahead to this slide because I personally find that the NAM 3 kilometer is the most useful for the Bay. The only downside with that is that it's generally fairly short term, so you might only get it the night before. Actually, I'll go back one. The NAM 12 kilometer seems to be pretty good for 2 or 3 days out. GFS is okay-ish if you're looking at a very long-term forecast, like maybe 6 or 7 days out. But if you're anywhere within 2 or 3 days of a day that you're hoping to fly, I generally find that NAM 12 kilometer and then 3 kilometer right beforehand will give you the best or the most useful data for the Bay itself. And finally,
let me add something. Can I add something there, Evan? Yeah, and a part of that makes perfect sense because GFS is the biggest grid. That's the 22 grid, the kilometer grid boxes. So NAM and the HR, I think they're basically getting their boundary conditions from GFS, but they are able to then run it at a smaller scale over a finite region, like the U.S. or over a section of California, let's say. But they're not having to run that small grid over the whole globe. But they're still getting their boundary conditions, kind of like what's coming into it from the larger scale model. But it's still all basically nested within GFS.
We have a question from Jug, and I'll just repeat it for people in the live stream. So Jug's question is, I mentioned that the NAM 3 kilometer I find is the best for the Bay Area, and he's asking if that's also true for the Sierras and for Mendocino. So I guess to summarize, is the NAM 3 kilometer generally the best forecast? I would say yes. It just generally does well, but again, it's one of those things where you're getting the data closer to the date. So, I mean, for example, if you're trying to plan a cross-country league meet the week before, I mean, you're not going to have NAM data, you'll have GFS. But I think if it's 3 or 4 days out and there are people who have flexibility to go to a certain spot, I would rely mostly on the NAM personally. Honza, do you have any comments on that?
No, the only thing is that the nice thing about when we go to, and that's going to be later when we talk about windy, the ECMWF is running a 9 kilometer of 10 days at least. So that's where, starting to compare the GFS and the ECMWF, you can start to, see how they agree. And it could be that the ECMWF is beating out the GFS that far out, and it's got better resolution.
Yeah, that's a good point. And we're going to do the comparison at the end. So I'm tempted to leave questions until the end, unless it's something burning or something that was unclear. Let's just do we'll do 2 more for now, and then I think leave other questions until the end if possible. Steve, yeah. So Steve is asking about smoke coverage. He mentioned that the forecast discussions usually do a pretty good job about mentioning smoke, and he's asking whether these tools here, so XC-Skies and Windy, will show smoke. The short answer is no. Smoke, it's really hard to.
Well, aerosols. XC, I'm going to say ECM. The Windy has an aerosol layer. You can pull it up. You have to add it, but it's a layer you can have as you can see an aerosol layer. Yeah.
Wow.
Windy has it. Yeah. You have to pull it up. It has to be an added. It's not like right off the bat, but you can add it in. It's one of the things you can have in your layers. So yes, you can get aerosols out of the East. I don't know about. I haven't seen it on XC-Skies, but I have seen it on Windy.
There you go. I had no idea. Okay, Julie. Yeah, so Julie's asking about the HRR and whether I had personally played around with it. I have in XC-Skies, I'm actually not even familiar with that other tool. Yeah, I think HRR it seems to be the best. The only problem is you only get useful data the morning of. So at that point, you probably should have already made your plans. But I have found that the NAM GFS and then NAM will say one thing, but then when you look at the HRR the morning of, and if it's saying that maybe something slightly different, twice now the HRR has actually picked up on something that wasn't there the night before, and it was generally right. That's not necessarily to say that's all the time, but it seems to be a pretty reliable forecast for the day. Okay, I think we'll try to hold other questions until the end because it's likely that we will cover them in the examples and some of the other tools. I'm also going to skip the live demo for right now, but we will get into a real forecast for tomorrow and for the weekend because we have some very interesting weather passing through. So I figure why not just do it for real right at the very end because I think tomorrow might be good. Okay, so on to Windy. So Windy, I personally find this to be the best and most useful tool. There is an amazing website. There are native apps for Android and iOS. It's particularly useful for visualizing surface winds and winds aloft and cloud cover and all kinds of other parameters. A lot of similarities to XC-Skies because it uses some of the same map data as well as the same model data. But some of the really cool features within Windy are that you get real-time sensor output, you get webcam images. If there are registered locations to fly, so somebody has already gone through the hard work and saying that this is a place where people fly, you can get a point forecast or like the equivalent of a point forecast for that particular location. From slide 2, I also mentioned that I'm pretty big into kiteboarding, and I use this tool just as much for that as I do for paragliding. It's surprisingly useful. I think if you're trying to figure out which tool to use versus XC-Skies, Windy has a lot of advantages. The native mobile apps are better than the mobile version of XC-Skies, in my opinion. I think the visuals are better. Honza mentioned this before.
It's free.
Sorry, go ahead.
I was going to say it's free. That's nice.
I forgot to put that on there. It's free. It's free, and you get ECMWF data, which it generally seems to be better for GFS for the longer term, and you also get a smaller grid. The creator of this app is paying for this data by himself and basically making it free to the public. So it's pretty awesome. The one disadvantage, actually the few disadvantages that it has versus XC-Skies are it doesn't have the top of lift prediction, which I think is arguably XC-Skies' most useful feature. And it doesn't have HRR data built in yet. Maybe it will have it at some point. And Hans and I were talking about this yesterday. There seems to be a strange bug in the comparison view. Actually, ironically, that's the screenshot that I took here. If you look at the map view and you sort of scroll through winds at different altitudes, and then you do this this comparison view, the data sets don't seem to match up. So I personally would rely on the map view. I think that is the correct data. I'm not sure what's going on with this thing here.
Yeah, the map, I think, here's what I found. The map seems to be correct. if you do a point forecast and you look at just its default ECMWF, and if you look at just that one, then you get overdoes the wind for some reason. But when you do the comparison of the 3 forecasts, then the wind off the ECMWF one disappears. So there is a little bug that we found. But the comparison is actually okay. It's just when you're looking at one forecast, and I've only at the moment tested it with the default one, which is the ECMWF. It tends to show the wind a little too windy when you look at the just be aware of that. But on the comparison or on the streak line view, that seems to be correct.
But I mean, you can't complain too much about a free tool. So
no, it's awesome, and they're pretty open in their like they'll work on it if you contact them. So.
All right. So moving on, sensors. I'll show this later during the live demo. Most of the time, to get live sensor data, you actually use I use the sensor tool within Windy. There are a couple sensors that are not registered on Windy, or Weather Underground is another tool that I use sometimes for sensor data, but I'm not going to cover that here. For the Bay Area proper, there are some sensors that have their own pages that are particularly useful. Mount Diablo, actually, that sensor is on Windy, but it has its own sensor page, which I've linked to here. I'm not going to show it now, but it has a really nice view of relative humidity as well as historical winds and current winds. So I kind of like to use that one. For some reason, Mount Hamilton is not registered in Windy. That's another really good one to look at just to figure out what's happening at one of the higher peaks in the Bay Area. Visible satellite. This is a really useful tool, particularly when you're trying to figure out what's happening with cloud cover, cirrus clouds in particular. And Steve mentioned before, if you want to see where the smoke is blowing, if there are wildfires in the area, you can actually see that showing up on the visible satellite, as well as some other views. And I mentioned GOES 16 here. I forgot what that stands for. I think it's Global. I'm not even going to try. You can look it up later. But basically, there's a new weather satellite, which it's non-operational right now, but you can already get the preliminary imagery, and it's going to be live, I think, by the end of this year. The difference in resolution that you get from the images from this satellite versus the old one, it's stunning. I basically hardly rely on the other one and exclusively rely on this one. So I put a link to the visible satellite page there. You can take a look at that later. But basically, the way to navigate that website, which sucks on mobile right now, but presumably within the next couple months is going to be better. Look for the Continental USA 5-minute imagery, and then you click on your sector, and there's one for Northern California. Unfortunately, it cuts off like just above the bay, so you kind of have to toggle between two views if you want to get a broader picture. But the images that come out of this thing are pretty incredible. I'm not sure if this is going to show up on the live stream, but here's an animation that I took just after the North Bay fires broke out. It's kind of hard to see, but all this stuff here on the top left, you can see where the North Bay is. The winds were east-northeast here, and you can see all this stuff blowing out to sea and just blanketing the North Bay. Interestingly, you can also see south winds to the south of the bay. So this is kind of at the end of an offshore wind event. So it was blowing northeast, but there was already this southerly surge of air which hadn't quite made its way into the bay yet. So kind of interesting to see. And there's some sort of low pressure system over the four corners there. So you can actually, it almost looks like it's snowing there. So pretty cool to see that. Anyway, GOES 16 satellite. It's pretty much the best. Webcams are really useful tools for determining real-time conditions, including wind speeds if the webcam that you're looking at happens to be pointing at a windsock, like we have at Mission. It's also useful for figuring out cloud cover in the area, as well as sometimes the inversion in the bay is quite visible, particularly if there's a little bit of particulate in the air. So I've put a link to some of the most useful Bay Area webcams here, which you can click through afterwards. If you want to broaden your search outside of the Bay Area, you can look on Weather Underground and click on their map view, and you get a bunch of webcams there. Windy also has a bunch of them registered. There's a really cool mobile app called IP Cam Viewer, which I use. And basically, it lets you register any image source or video source. And I'm not going to do a demo here, but you can try downloading it. There's a free and a paid version. Paid version, I think it gives you more webcams or a faster refresh rate. I can't remember the difference. But basically, it lets you really quickly toggle between different webcams, and that's what I used a lot of the time for the Bay. The SKU-T, as I mentioned before, it's going to be very easy to get caught up in this. I'm going to turn it over to Honza, and I will cut him off if he starts to go too long. But basically, the sounding or the SKU-T is a very useful tool for looking at current conditions. It's useful. So basically, there are balloons which are sent up twice per day. For us, it's at 5 a.m. and 5 p.m., and it gives you a real-time profile of the atmosphere. So it'll show you winds aloft, humidity, dew point. I'll turn it over to Honza at this point to do a brief explanation of what this SKU-T is.
Yeah, so it's basically it's a kind of intimidating-looking chart, but it's very useful. You on the right is the plot of the environmental lapse rate, what the atmosphere looks like as you go up with height at that time and place. So it's plotting the temperature on to the right, and then on the left is the dew points temperature. And then you have the wind barbs that show wind speed. It's worth taking some time to learn to read these, because then you can, a quick scan of these. I keep the Oakland sounding and the Reno sounding on my phone, and I check that pretty much daily, just out of curiosity at what it's looking like. And then if you're living more in Northern California, Medford sounding can be useful. But it's like a little fingerprint, and you see it, and it's just every one is going to be a little bit different. But certain good days have a fingerprint, and what you look for, the one thing I look for is how deep is a layer that's dry adiabatic and that's fairly near the surface. So when the temperature trace is basically leaning 45 degrees to the left, then it's basically the environmental lapse rate is matching the dry adiabatic lapse rate, and within that layer, thermals are free to rise. I mean, air given an upward impulse is free to continue rising in that layer. And then also you see the opposite of that is if that line starts going straight up or leaning to the right, then that means it's stable, or even more stable, which can be inverted. And of course, that'll bring any rising air to a halt. So, and sometimes looking at what it looks like above a marine layer, even if I see it as a thin marine layer, then I think, okay, I can go inland, but I see it's a good stretch of a dry adiabatic layer. That means it's going to be pretty good a little ways inland. So these are definitely worth learning to read. I know we have windy and XC skies and all that, but the fact that we have a sounding in our area is a privilege. These are scattered about 200 miles apart, and having one right there is just a great privilege, having the Oakland sounding. So it's very useful, I find.
All right. So we will cover a couple examples of soundings when we go through the how to pick a site section at the very end. There is one last tool here, and I think a lot of people are not necessarily aware of this tool, but it's particularly useful for the Bay Area. It's called a profiler, which is a wind and radio acoustic sensor. You can almost think of this as like a real-time sounding, and basically what you get here, actually, I'll just go through the slide first. The first link is a link to all of the profilers in Northern California. The most useful ones for our area are the Bodega Bay profiler, as well as the Fort Ord profiler. And there is one in the Central Valley. But essentially what you get here is you get a near real-time plot of the boundary layer wind, temperature, dew point, and mixing height. And the way to read this is on the left side of the chart, you get you get the freshest data. So it's almost like a ticker tape. And every time the profiler refreshes, you get new data showing up on the left. Time is on the bottom, so you'll get the local time. Altitude on the left. This looks like feet in this one. Yeah, actually it says feet above sea level. I think if you go to this page, it's a mix and match between meters and feet and degrees Celsius. It's kind of a mess, but just make sure you know which units you're looking at. And of course it's color coded by temperature. So this example here is actually kind of interesting. This was from, I don't think the date is there. Oh, there it is. August 21st. So summer. This is an example of one of those days where there's a marine layer up to like 2,000 feet, but it's actually unstable within the marine layer. So you can see here it's purple, which is 14 degrees Celsius, 16. Yeah, 16. Now it's starting to warm. So like somewhere around 1,800 feet is where the inversion is. And then you can see above it, it goes all the way up to like 24, 25 degrees Celsius at 4,000 feet. But if you look here, it's like 16 degrees at the surface. Actually, this is too late in the day. Let's look at like maybe 3 o'clock p.m. So it's like 20 degrees Celsius at the surface. Whoops, too far. 20 degrees Celsius at the surface, but go up to like, I don't know, 1,500 feet there. And we're at 15 degrees Celsius. It's not bad. Mission Peak is like 2,000 feet. You could actually soar within that, not necessarily getting above the peak, but actually have unstable conditions within this little slice of air. And it can actually be really, really fun to fly in. So yeah, the profiler is useful for understanding the real-time condition of the atmosphere in the Bay Area proper. Cool. So that's pretty much it for the tools part. But I think the final part of this presentation is taking all of that knowledge that we've learned and figuring out how to pick a site given a certain set of conditions. And the way I've organized this is I've taken 3 examples of some pretty good flights that I've had recently within the past couple of months. And yeah, we'll just see what the forecast looked like before and how the day turned out. Unfortunately, I was not diligent in capturing screenshots from XC Skies or Windy. Basically, what I have are the historical forecast discussions as well as the historical soundings. But I think at the very, very end, when we do a forecast for tomorrow and for the weekend, we can go through XC Skies and Windy and just kind of see how to toggle through the different pieces there. So let's go to the first example, which is from May 7th of this year, where I once again flew from Mount Diablo to Alum Rock. That was a good day. So just a quick summary of the conditions as I remembered them. Basically what happened was there was a low pressure system that had passed by the day prior. So it sort of dropped, I think it came from the northwest and kind of dropped to our south. So there was still this fairly cool pool of air that was left behind. But high pressure was starting to fill in. The atmosphere was starting to stabilize the next day. And again, if you think of low pressure being just off to our south, maybe southeast, if you think of a low pressure system as spinning counterclockwise and we're on the, I guess, top left quadrant of that, the prevailing winds there are going to be northeast. Same thing, if there's high pressure nudging in from the west, high pressure circulates clockwise. On the bottom right quadrant of that, the winds are also northeast. So I guess the message to take away from that is that prevailing flow that day was starting off as was northeast, which is the direction that you're generally flying if you're going from Mount Diablo to Mission Peak. Oh, and also there was this really cool convergence that happened over Pleasanton. That was fun. So forecast discussions. I think at this point, let's switch to presentation mode. So I'm actually going to exit out full screen. For those who are following along in the presentation online, I did not want to paste an entire forecast discussion into a slide. If you open the slide notes, though, what you should see, is this showing up on the live stream? I'm not sure. Okay, cool. I just pasted the forecast discussion in at the bottom of the slides, so we can just read through it here. I'm tempted to read through the whole thing, but that's probably going to get boring pretty quickly. So basically, forecast discussion from 2 days prior, and then the night before, and then the day of. So interesting thing to see here. We'll just read the synopsis and maybe pick out a couple key things. Yes, that's right. Yeah, so this is 2 days before. I was already starting to get excited about the weekend, and I'll just kind of walk you through my thought process for why I chose to go there on that particular day, and like what were the signs that I was seeing 2 days before that this flight might be able to happen. So cool and breezy conditions are forecast through Saturday. Slight chance of thunderstorms across Monterey and San Benito from late Saturday through Sunday. Warming and drying will occur across the north beginning Sunday and in all areas Monday and Tuesday. So that's a good sign. We know it's really unstable. We know there's cold air. I can't remember exactly, but I think we actually did get some thunderstorms in the Bay Area. But the trend was for it to dry out. So I mean, this is kind of the fingerprint of what could make a good day. We have this cold, unstable air, but just on the tail end of that, when it's starting to stabilize, but it hasn't gotten too stable yet, that's what you want to look for. Let's see. So discussion, again, it's probably worth reviewing this afterwards, but an upper trough continues to deepen near the west coast this evening. Cooling temperatures, let's see. Here's the interesting part. Winds have been gusting over 40 miles per hour at San Francisco Airport and Point Reyes since this afternoon. So there's really cold, unstable air mass have come in. And let's see. A cutoff low is forecast to develop near Central California coast on Saturday. This unseasonably cool upper low will maintain cool conditions across our region tomorrow. So this is another good thing. It's early May. We know we have a good sun angle. We have good ground heating. There's an unseasonably cool upper low, so we know we have cold air aloft. Like all the ingredients are clearly lining up for there to be some good flying conditions coming up. The one thing I was worried about was that 40 mile per hour wind at San Francisco. We can't fly in wind that strong. Yeah, so that's it was a bit of a red flag. I was a little concerned that the winds were going to be too strong. I mean, generally good conditions in place, but strong winds, so something to be aware of. Okay, so I think that's enough for this one. Let's go on to the next slide. This was, forecast discussion from the evening prior. So this was on Saturday night. So let's see what the synopsis is. Cool and breezy conditions will persist through the remainder of Saturday evening. Showers across the southeastern region, or portion of our region overnight. Showers lingering across the far south into Sunday. Otherwise, expect warmer weather on Sunday along with lighter winds. That's good. So, again, the same general pattern is in place. We had this cold air, but now the forecast discussion is still hinting towards it stabilizing on Sunday and the winds being lighter. So now is the point where I'm starting to get excited because the one thing I was worried about before was strong wind, but now the forecast discussion is suggesting that may not be the case. So here's a review. Saturday was a cool and blustery day across our region with high temperatures mostly in the upper 50s and 60s. So that's like, what is that, like 15 to 20 Celsius. Coastal and higher elevation locations were buffeted by northwest winds that gusted as high as 40 miles per hour. Yeah, that's pretty strong. One interesting thing, and I learned this, or I guess this was reinforced from talking to Josh when he flew from Blue Rock to wherever it was in the Central Valley, Madera, I think it was. It was somewhat similar conditions. The conditions that day out at the coast, I think Mike might have actually been sailing that day in the bay. I can't remember. But it was blowing something like 30, 40 knots out at the coast, but it was light enough inland to be able to make it work. So just because it's blowing really strongly out at the coast where there's this long open stretch of open water, not really any terrain to get in the way, just because you're seeing 40 miles an hour out at sea does not mean that's necessarily going to be happening inland. But something to be aware of. It means that there is the potential for strong winds. Okay, so blah, blah, blah. We could read over the forecast discussion. Now let's look at the sounding from, this is from the night before, I think. May 6th at 5 p.m. Yeah, this is the afternoon sounding from the day prior. So this is, I probably should have been flying on this day also. I mean, if you look at this line here, this is the environmental lapse rate. It's basically tracking the dry adiabatic lapse rate all the way from the surface up to, what is that, 1,500 meters? So that's like 4,500, 5,000 feet. Look at the winds here, like 5 knots, light here, stronger above, but I mean, we're not getting anywhere close to that high. So yeah, I mean, Saturday late in the day probably would have been a good day. It might have been, the cloud base might have been a little bit lower actually, but I mean, that still looks pretty good. Okay, so now here's the morning sounding the day of. So this sounding comes out at 5 a.m. So even I live in Palo Alto, it's like an hour drive to Diablo. It's like 2-hour hike to the top. So even the morning sounding is still useful for making a determination whether it's going to be a good day. So let's see what happened here. Surface winds kind of increased overnight and actually started to switch to more northerly compared to what we saw yesterday. The winds aloft, and this is kind of where it gets interesting because we know there's going to be some mixing happening here. If you look at the wind barbs, those are coming from the northeast. The lower atmosphere has dried out, so you can see the dew point line it's not as close to the environmental temperature line. And the other thing here is that there is a surface inversion present. This thing keeps popping up here. Yeah, there's a surface. I'm going to get out of this thing. This little pop-up is making me irritated here. Let me just zoom in. It's a little bit small. Still good enough just to see this line. So here's the inversion. You can see the temperature goes up and to the left, and then there's this massive inversion. But we know it's the middle of May. If you were to extrapolate this line all the way to the bottom, that would bring you to 20 degrees Celsius. It's pretty likely in early to mid-May that the surface temperature is going to be somewhere around 25, 26. It's going to be cooler aloft. So you can effectively ignore this inversion because it's going to mix out fairly early in the day. The other thing is to notice the temperature aloft is still fairly cool. So this might have happened earlier rather than later. Let's see, forecast discussion from the Sunday morning. I'm going to read over this one, and I think that's going to be it for this example. Let's see, shower chances will continue across the far southern portion of our forecast area today. Otherwise, dry conditions with warmer temperatures and lighter winds. So that sounds good. Time to fly. Here's the discussion. Mid-upper level low remains parked over Southern California. So what was over the Bay Area 1 or 2 days prior has now made its way south. Let's see. This resulted in overnight and early morning showers across portions of Monterey and San Benito. That's far enough south of the Bay that we can basically ignore it. And now, meanwhile, sunny conditions prevail across the North Bay, where afternoon temperatures will likely be warmest across the region, generally in the upper 70s to lower 80s in the valleys. That's like mid to high 20s. So again, reading this and then looking at that morning sounding, I knew that morning inversion would mix out, and you can basically extrapolate that line and just try to figure out how high you're going to get that day. And that's basically it for that flight. Oh no, actually, I forgot. This is the really important part. The Mount Diablo summit sensor. I'm going to go back into full screen for this one. If you ever want to fly Mount Diablo, keep note of this pattern, because this is something that is present more often than not. So this is from midnight the night before, 7 a.m. all the way to midnight the next night. So it's a 24-hour period. Let's look at the graph on the right first, which are the winds. So this is in miles per hour. So it's gusting to 32 miles an hour at 7 a.m. It's still 24, gusting to 28. The direction is this orange thing here, which is sort of northwest. But we can see as of like 9 o'clock, it's sort of switching from more northwest, getting a little bit more north. And here's like maybe 10 o'clock in the morning, the winds have now dropped off to 15, gusting to 17 miles an hour. The wind is now almost due north at this point. I think I launched probably around 12 o'clock, and look what happens here. winds have dropped from like 4 miles an hour to 2 miles an hour to like it's basically light and variable. The winds are all scattered all over the place here. That's just thermals blowing through the summit. But basically what happened was the wind clocked around from northwest to north to even a little bit northeast. And from around 12 o'clock to the afternoon, I mean, it was good. So this pattern is it's quite common at Mount Diablo. So even if you're seeing winds of like 30 miles an hour in the morning, and it's generally north to northeast winds, unless the forecast discussion is calling for sustained northeast winds or like a north wind event, it's pretty likely that the winds are going to drop off and be flyable. And also just look at the sounding, see what the winds aloft are doing. If you think if it looks like it's going to mix and there's very strong winds aloft, it might stay windy at Diablo. But if just above the inversion, it's not that windy, I mean, it could very well look like this. Lastly, look at the temperature, and here's where it's pretty cool. Red is temperature in Fahrenheit. So let's look at what it was in the morning. It's like 38, 40 degrees Celsius. That's like 5-6 degrees Celsius at the top of Mount Diablo, which is like 3,800 feet, I think. So what is that? 6 or 7 degrees at like, let's say 12 p.m., maybe 10 degrees. I don't know. But if it was going to be like 26, 27 degrees at the Celsius at the surface and maybe 8 to 10 degrees at the top, that's a really good lapse rate. I mean, you're going to get high. So again, this is a pretty interesting graph to look at, because I mean, it's like the fingerprint of a very good day at Diablo. And afternoon sounding, here's where it gets really interesting. If you were to look at this, you wouldn't have thought it would have been a good flying day. But the things to note are the winds aloft switched very much to northeast. This is at 5 p.m. It actually looks stable here. There's even a weak inversion present, which actually did happen. You got some stable marine air pushing in at the end of the day. But at 5 p.m., at this point, I was already past Ed 11, where I wanted westerly winds anyway. So it was largely a function of timing. So basically riding those unstable or riding those northeasterly winds to get over to where Mission and Ed 11 are. And then at this point, even though the air was somewhat stable, it was basically just kind of hopping along on those light westerly winds that were present at the end. So the atmosphere really stabilized by the end of the day, but it didn't really matter, because the challenging and arguably the more important part of the flight happened before the atmosphere looked like this. So yeah, that was a pretty cool day. I think I just want to do a time check. I know we're at about an hour and 10 minutes at this point. I'm tempted to skip over this one. You can read over it and then just do one more example. Do a real-time forecast, and then we'll do Q&A. So skip. It's another Diablo flight, kind of similar, a little bit windier. So this flight is from September the 22nd, so pretty recently. Yeah, this is like the best day ever in the Bay Area. Yeah, that was cool. Great lapse rate, light north winds aloft.
Hey, Evan.
Yeah.
This is Honza.
Go ahead.
I just want to chime in with Diablo before we leave Diablo.
Oh, yeah.
Just wanted to give a shout out to Ed Stein, who is the sort of the pioneer from the 90s of Mount Diablo, and he's always told us to just go, and has been an inspiration for a lot of the newer generation for just getting after it.
Yeah, I can attest to that. Ed is probably one of my largest inspirations. I've only flown with him a handful of times, but just listening to him, he's like Yoda. Like, you just like listen to his words and good things happen.
Yeah.
Okay, so I'll just talk about the mission to Highway 152 flight from a few weeks ago. So yeah, it was the best day ever. Very light east wind aloft was predicted. And it was very interesting because this actually showed up on XC skies. And often you'll see like bright yellow or orange colors, like the good colors that indicate a good top of lift. But very interestingly, it actually had migrated a little bit further out over the front hills. And I figured, if there's light north and a little bit of east wind and a really good lapse rate, there could actually be a weak convergence that sets up just from the prevailing westerlies that come in over the front hills. And that actually happened, which was pretty fantastic. This day was interesting because it was a mixture of blue thermals, so not thermals that were not necessarily marked by clouds. There were some good thermals that were very distinctly marked by clouds, and there was this incredible convergence that set up basically from Metcalf Road, which is just at the south end of San Jose, all the way to Gilroy, and even beyond, but I ended up landing here. So forecast discussion, let's go back to this one here, September 20th. Yeah, so this is 2 days before. So we'll do the synopsis. So a cool upper level trough will dominate the western portion of the country through the work week, maintaining cooler than average temperatures and breezy conditions. Sounds kind of familiar, right? Cool weather, breezy conditions. So again, the things that I were worried about were that the winds were going to be too strong for flying. That's often the case. It's a fine balance between having cold air, but along with that, you get breezy conditions. So just watch the winds. So a weak cold frontal boundary remains draped over north central California this evening. Some light showers over Santa Cruz. This is the first rain of the season, so that's always exciting. Blah, 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 convective precipitation. Here's where it gets interesting. A cooler air mass will sweep across our area with a trough on Thursday and the flight was on Friday, with 850 millibar temps now forecast to drop as low as 4 degrees Celsius. So 850 millibars, I forgot my conversions. I think that's roughly Mount Diablo height. Either way, not too far from the surface, 4 degrees Celsius. That's a good, really good lapse rate. It's going to be unstable. Very interesting thing happens next. Breezy conditions will develop in the afternoon, especially near the coast, where wind gusts of up to 40 miles per hour are possible late Thursday afternoon and evening. And here's where I start to get excited. Winds will then diminish late Thursday night into Friday. This cool air mass will mean chilly nights for the remainder of the week and into the early part of the weekend. So that's good. Winds are getting lighter. There's still going to be cool air in place. Sounds pretty good to me. The coolest nights are expected to be Thursday night and Friday night. Okay, so that's good. Don't need to read the rest of this. Let's go to the next one. This is one night prior, so I think we'll just do the synopsis for this one. Actually, the synopsis is kind of useful. Let's see. Cooler air mass arrived last night, resulted in cooler temperatures across the board. Let's see. Widespread 40s are possible overnight, with several pockets of mid to upper 30s possible over elevated inland areas. So we can see again, it's going to be really cold. Breezy conditions were observed once again this afternoon along the higher elevations, gusts to 54 miles an hour. Okay, so it's still strong, but now let's, you know what, I'll skip the sounding the day before, unless there's something useful there that I forgot. Oh, actually, this looks really good too. This is the 5 p.m. sounding the day before. Generally looks good. So I think that forecast discussion, it didn't capture the winds that had already lightened up at this point. Like, it was still calling for strong winds, but by the time the sounding happened, the winds had already dropped off, and this generally looks pretty good. Cloud base at 1,500 meters, which is like around 5,000 feet or so. Forecast for the next day was similar with lighter winds, so everything is looking good. 5 a.m. sounding, the day of. Let's zoom in, see what we see here. I wish there was a way to hide this thing. But no. I want to see what the temperatures are at the bottom. But whatever. Maybe this thing. No, that didn't work. All right, I'm going to get out of this thing and just deal with it. Okay, so basically, if we look at the temperatures aloft here, so the daytime temperature was forecast to be, I think it was close to 20 degrees. So what you can do here, so you can see there's a little inversion here. The temperature profile stabilizes here. You could, just for fun, you could extrapolate this line all the way down to 20 degrees.
Super small. Maybe you can the picture up
Yeah.
a little and then go to presentation mode. Just edit your slide.
I have an idea. See if I can zoom in. Oh, that made things way worse.
Arthur's idea seems good. Just push it up so it's not as close to the bottom of your slide.
Yeah, I like that. Brilliant. Thank you. Okay. So yeah, let's see. Let's just for fun, let's draw a line from like 20 something, 22, 23 degrees up to this point here. You can see that, whoops, the profile on this upper part here, it's almost matching the dry adiabatic lapse rate. And this is around 2,000 meters, which is like 6,000 feet. So like basically if the day heats up to like mid 20s Celsius, there's actually the potential here to get up to like 2,000 meters, which is like 7,000 feet. But there's a little bit of stable air and an inversion. So what I expected might happen would be, it would be really challenging flying, like really just have to work every thermal, try to make some progress before the day really heats up. And then at some point in the afternoon, things could potentially get really good once the temperature at the surface heats up, and then you get rid of all these inversions at the bottom. So that's kind of what I saw over here. Okay, forecast discussion from the morning of. Let's slide this up. Okay, so gradual warming trend will begin today. So again, same thing as last time. We had this unstable cold air mass. We're now on the tail end of it. It's starting to stabilize, but we still have all this cold air present. As the region transitions to a warmer pattern, temperatures will approach seasonal norms, still maintaining moderately breezy conditions. Okay, so a little bit worried about wind, but let's see what happens. Blah, blah, blah. Just want to see if there's anything useful here. Marine layer remains mixed out as a cooler, drier air continues to advect in aloft, hampering any chance of an inversion. So that's good. It means it's not going to be inverted. It's probably going to be unstable. I'll skip over this. There's not too much useful information here. Let's look at I'm going to do the same hack over here. This is the 5 p.m. sounding. So this is what the day looked like after the fact. And this is pretty cool because you don't often see soundings like this for the Bay Area. So let's see what happened here. Oh my God, look at this line. Basically, my highest altitude on that flight was 7,200 feet. That was the highest I've ever been. Not in the Bay Area. I've been higher at Mount Diablo, but basically anywhere along the front range between Mission Peak and further south. So there's like a little inversion here. It may have stabilized, but I mean, at this point, some of this may have just been from some marine air filtering in, like sort of filtering through the Golden Gate and making its way to Oakland where the sounding is taken. But this whole thing is effectively pretty unstable. The really interesting thing here is look at the winds aloft. Very, very light northeast, actually. So this is how that convergence set up. And here it's actually due east, if not maybe even like a little bit southeast, which I actually did feel at some point on the flight. Like some of the thermals that topped out, I actually started drifting back just a little bit to the north. And of course, very light west winds at the surface. So like super light winds all around, unstable atmosphere. Like this is like, it doesn't get much better than this for the Bay Area.
Hey, Evan?
Yeah.
Yeah, that little that bottom west barb, that's exactly what you're saying is probably the wind coming through the Golden Gate and just stabilizing it out a little bit. Just that's a little bit of a marine influence onto Oakland. But by then you're far away from it on your flight by that time.
Yeah, exactly. And the interesting thing about flying at Mission and Ed Levin is the further south you get, the farther away from the bay and that marine air you get. So basically, if you can just get away early and make your way south, it's likely to, like, the conditions are likely to be better, and you can just escape any of that stable marine air if you make your way south fast enough. Oh, whoops, that should be full screen. And I think I think that's it, except for figuring out where to fly tomorrow, which I will cover after this. Yeah. Does anyone have any burning questions, or should we do a quick forecast for tomorrow and then just do the Q&A at the end? Just show of hands around the room if anyone has anything that they want to ask. Yeah.
Have you talked about blip maps?
Blip maps? So for those in the live stream, question is whether I am talking about blip maps. The answer is no. I personally don't use them that much. That's not to say that it's not a useful tool, but I'm just not going to cover it today. Yeah. So the follow-up comment was that we did cover XC skies, which relies on much of the same information. So yeah, I think that it's a good comment, because a lot of the tools that we use, they all rely on the same or similar underlying data. So it's just it's a different visual representation of the same data. So you can kind of Interesting. So comment is that some of the sailplane pilots have come up with a refined version of blip maps. I'm personally not familiar with it, but worth investigating. I like new tools that are useful for flying. All right, so I think just to conclude this before we move over to Q&A, so let's keep it on presentation mode if it's not already there. Let's do a quick assessment of what the forecast for tomorrow looks like and the weekend. Okay, so I preloaded some of this data here. So again, look for AFD, NWS, Monterey. So let's look at the forecast discussion for tomorrow. This is what it looks like. I'm going to zoom in here. That's pretty good. So 5 p.m., this is fairly recent data. And let's see what happens here. A cold front is still expected to move through the area later today, probably happening right now as we speak, actually. Bulk of rain will be in the North Bay Mountains and coastal ranges, along with precipitation. Expect cooler temperatures and breezy onshore winds through Friday. By late Friday morning, dry conditions will return, lasting through the forecast period. This sounds familiar. It could be really good tomorrow, but let's see what's going to happen with the wind. A warming trend is then on the way over the weekend and into early next week. Temperatures are predicted to be well above average during the beginning of next week. Okay, let's see if there's anything useful here. Cold front is approaching, along with precipitation. Breezy southwesterly winds will accompany the frontal passage. Okay, so that's today. Today's already happened. If anyone flew today, awesome. Good for you. I did not. Let's see what's good. Yeah, it looked decent today, actually. Yeah, it looked good. All right. Oh, for tomorrow. Some areas in. Oh. Yeah, rainfall. Yeah, so it's the forecast discussions over the last day or so. It's sort of been changing the timing. At first, it was saying that rain was going to persist until midday Friday. Now it looks like it's saying it's going to be out of the San Francisco Bay Area by tomorrow morning's commute. So that could be good. The rain clears out, and then nice. Yeah. So it's been a little bit more progressive than the earlier forecasts were saying. Okay, so tomorrow has potential, and we'll confirm that with the other tools. Warming trend is on tap for the weekend as an upper level ridge starts to build over California. It's going to be strengthening. 850 millibar temperatures are forecast to approach 25 degrees Celsius through midweek, flirting with maximum climatological values for this area. That's interesting. The ridge, along with light offshore flow, will result in warm and dry conditions across the area Monday and Tuesday. Okay, it sounds kind of interesting. Yeah, go ahead.
It's going to be 102 in LA, they said, Evan.
Wow. Southern California is calling for potential record-breaking heat. So I think it's a combination of warm temperatures aloft and also these northerly winds, which brings Santa Ana's down there. So it's kind of interesting.
So which of your three telltale signs do you see?
So Well, it depends, because for tomorrow, it's sign number 2, which is cold air aloft, cold air remaining before the stable warm air pushes in. But then we're transitioning to scenario number 1 or 3. I can't remember which it is, which is basically the inland air sort of blowing out to sea. So the next couple of days could be interesting, because tomorrow we're still having that cold air aloft where things are going to be unstable, and then beyond that we're getting this offshore flow which is potentially blowing away all of this stable marine air. So worth keeping an eye on the next couple of days is I think is the message to take away from this. I would like to. We'll see. Okay, I think that's probably all the useful information from the forecast discussion. So let's go over to XC skies first and see what we can see here. Okay, so XC skies, I'm going to skip over GFS because right now we care about tomorrow and Saturday. And I think, as I mentioned before, NAM and the HRR, actually HRR is not going to show tomorrow. So probably the NAM 12 kilometer and 3 kilometer are going to be the most useful. So let's look at NAM 12 kilometer for tomorrow. Let's just start at 9 a.m. for fun. Okay, so this is 9 o'clock. This is the winds at top of lift. Just for fun, I'm going to bring this to, so 600 meters is around 1900 feet. So this is roughly the top of Mission. Winds look okay-ish there. There's a little bit, the wind barbs are knots, by the way. So one long stick is 10 knots, a small one is 5, so that's 15 knots here. Yeah, 15 knots is a little breezy, but it could be okay. Let's just skip forward to 12 o'clock. Not much wind, actually. It actually drops down to 10 knots at 12, 1, 2 o'clock. Here, there's a little bit more wind in the afternoon. So now we're seeing 10 to 15, but that's still pretty reasonable. Just for fun, so it's saying that the top of lift here is bright green, which is, let me move this over. That's about 2,400 meters. That's pretty high. So what we should also do is look at the winds aloft, because some of this, some of the stronger wind aloft could have the potential to mix down. So we want to make sure is that the wind aloft is not too strong, just because it could have the potential to pick up later in the day. So, what's that? I could. I'm not going to do it now, though. I don't want to open up the settings. But, oh, we lost Honza. I will dial him back in and. Yeah, I could, in the interest of time. I'm not going to right now. But basically, I'm not from America. I think in metric. I do conversions.
You're comfortable with flying or launching?
Did we sound this phone? I'll try to get back to you as soon as I can.
Oh,
thanks.
We'll see. Well, let's see. Launching. Let's look at. I would probably be launching by 12 o'clock tomorrow. It's saying 10 knots or so.
Well, look at the bottom. It says the actual 12 knots.
Where does it say that?
If you look at the word Fremont, go to the right. You look at the right.
Oh, that's. Oh yeah, I forgot about that. Maybe. So it's again.
I just
Yeah.
want to see if we're calibrated the same way, where it's like 12 knots at launches. Maybe.
Yeah.
You need a very strong thermal to not get blown out.
Yeah.
Right?
So it's again, it's sort of, it's borderline. There is the potential for strong winds. So it's something to be aware of. I'm not sure if I would fly tomorrow, but it's worth seeing what the webcam is doing in the morning, and I guess making that assessment closer to. Yeah. Oh, I think Hans is trying to get back in.
Yeah, exactly. I like this forecast.
Okay, I'm going to try calling him back again. So yeah, I think the takeaway from this is that tomorrow has potential. If we go even higher, you can see stronger winds, sustained 20 knots, 15, 20 at. Hey, Honza.
Hey, yeah, it got dropped for some reason. I'm back.
All right.
Thanks.
Yeah, we're just kind of going through XE skies for tomorrow. So yeah, I guess the summary is that top of lift looks generally good. Winds could be a little bit strong. NAM 3 probably won't be. Oh, actually, yeah, it only goes to 11 o'clock tomorrow. But interestingly, let's go to.
Oh, so I thought the other are just longer intervals, but it's still.
Yeah, I'm actually. It goes to 11 o'clock, and then you can switch ahead here. I'm not sure how much confidence these ones have, like when there's the big gaps in between these ones. Anyway, I don't want to ramble on too much here, but I think the summary is that tomorrow has the potential to be good, but it could get windy. So just something to be aware of. Just for fun, let's look at Saturday on GFS just to see what's happening with the winds. And this correlates, let's go a little bit higher just for fun. This correlates with what the forecast discussion was mentioning. Like it's kind of stabilizing, this high pressure is building in. Let's go a little further in time. It's switching even more north. If we were to go to Sunday, look at that. It's already switched to northeast. So the professional forecaster has already done all the hard work for us and has shown us that it's going to be switching to northeast. Now let's switch over to windy. And, I'm in the wrong place. Let's see what's happening in the Bay Area for Friday at 11 o'clock. So I'm going to get rid of this. Zoom in to, let's look at mission just for fun. So light blue this is like 10 knots or so. Let's move it over. And this is ECMWF, by the way. So this is like the longer term model. Yeah. Yeah, but this is where it might, this is where it might mess up though, where it shows, yeah.
Oh, you see it on the flag as well, just there where
What's that?
just up there on the flag, you see the 6 knots as well.
Oh, yeah. Yeah, it gives you a point for whatever time it was. 6 knots. If we were to go higher, 5 knots. So generally light. But this is at the surface, though. Let's go to 12 o'clock. 2 o'clock. Okay, 2 o'clock, we're starting to see some stronger surface winds, like 18, 20 knots, but that's in the middle of the bay. Let's move the slider up to 2,000 feet. Let's go to 2,500 feet. Okay, so this is a little bit concerning. Now we're seeing sustained 20 knots roughly. This is like mission 11. It looks a little bit windy. Probably okay for hang gliders. Paragliders, yeah. 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 So I don't know. Tomorrow, I think there is potential still. It's worth looking to see what the sounding in the morning and what the HRR says in the morning. But given that ECMWF is saying strongish winds, XC Skies on NAM was saying strongish winds, it's probably going to be a little bit on the breezy side tomorrow. So I guess I'll go to work. I guess just to wrap things up, I'll just do a very quick run through of windy. So reported wind, if you click on this little icon here, this will give you all of the real-time wind sensors in the area. And you can click on each one of these. I think that one's Rose Peak. Oh no, that's in Tracy. Really? That doesn't seem right. Anyway, whatever. It is Rose Peak. So really nice graph here. It'll show you the temperature. It'll show you the winds. You can change the slider just to have a more granular view of the last, whatever it was, 24 hours or so. Yeah, that's basically it for the detail sensor view. The webcam button is over here. So if you want to see what webcams are available in the area, obviously we're not going to see anything at this time of day, but give it a second, and then you basically get all these webcams that you can click on and see. Oh, that one's kind of pretty. Yeah, so you can see all kinds of different data that's available. Yeah, I think that the UI here is generally pretty easy to use, but that's what you get. Question from Ben.
Yes, I'm intrigued about Windy Hill, for example. You feel like there's a potential for some.
I think we might be thinking the same thing. Let's. let's okay, just for fun, let's see what's happening Saturday at the surface at Windy Hill. Let's only do this one in Windy just for fun. So Windy Hill is roughly here, Portola Valley. Whoop, too much. Let's go to 9 o'clock. Northeast winds. Let's actually bring this up to 2,000 feet, which is roughly just above Windy Hill launch. Strongish wind in the morning, but we know that it's supposed to get a little bit lighter. Oh, never mind. It's actually getting stronger. Yeah. So the trouble is, remember how I said that out of the coast, it doesn't necessarily matter what's happening there if you're trying to figure out what's happening inland. Windy Hill is kind of closer to the coast than some other places. So this really strong stuff that we're seeing out at the coast actually does have the potential to affect Windy Hill. So yeah. Yeah, exactly. Let's
Do you ever use the NAM3?
Yeah, so let's see what the NAM3 is doing. It's probably not going to have until... No, actually, it has a bit of Saturday. 2,000 feet, it's still showing like 20 knots. Direction is good. Strength is a little bit on the strong side, so we'll see what happens. Yeah. Yeah. So comment was that in Santa Cruz, predictions from Windy are often 20 to 30% lower than what it actually is. I think that's also a function of the particular site. And Honza mentioned this earlier. Like, it's take all of this model data and build your own mental model of your local site based on what happens. So if you're seeing, like, if you notice a pattern where it's often 30% stronger than what you're seeing on Windy, it's probably going to be 30% stronger if you know that site well and you know its local patterns. Cool. So I think just to interject, this is pretty much the end of the presentation material. So I think we'll turn it over to a formal Q&A session. We'll do some room questions as well as some online questions. But just want to do a quick check with Honza because I'm not sure how long you can stay around, but yeah, just want to see if you can stick around for a couple of Q&A.
I'm fine, Evan. I'll stick around if there's any questions I can help out on. I'll be happy.
Okay. Yeah. Actually, you know what? For the Q&A part, let's have people come up here just so you can be on the webcam and also just so that he can hear the questions directly because I'm speaking into my phone. We'll do this here. Okay, come on up.
Yeah, Hamza, I have one question for you. And I was wondering, we talked about the differences between the model in terms of grid resolution. I wonder if there are other differences as well. I mean, I don't know, maybe some kinds of physics that get modeled in one model or not the other. And the background basically is that I had the impression that the evening before for Dunlap that NAM12 worked way better for me in terms of the prediction for the top of lift than NAM3, which I find weird because NAM3 is supposed to be more accurate. So I don't know if there's an explanation on the basis of what's modeled in the model.
Yes. I'm personally not sure on the two NAMs. I know the assimilation for the global models is, the ECMWF is reputed to have better assimilation of the observational data, and they initialize a new run only twice a day, every 12 hours, whereas GFS has it on a coarser grid, but they do it every 6 hours, so that can catch, like, if something is developing really fast, they can kind of adjust for that. But for the regional models, I don't know. I don't know exactly between the NAMs. I can't say. Sorry.
Yeah. Next question. Come on up. He's talking to the phone also.
Okay, cool. So while we have the experts here, one burning question I had was, over the years, especially at the coast, those that know this site often talk about the idea of a heat block, or people say there's a heat bubble, and that's why the winds aren't coming in. And I was just curious about never quite understood that, and so I was wondering what the explanation of that was in the context of stuff we've talked about.
I would like to address that. I've heard that one talked about even since back in the day I started flying, and people down also in San Luis Obispo talk about this thermal block. I think that's actually not a real phenomenon, personally. I don't think a warm bubble close to the coast would hold off marine air. I think it is more of a stagnation that occurs. You get a lot of stagnation zones. A lot of times what the air feels is not what we see as the terrain. You get a lot of kind of air that gets rammed up somewhere, and then air might ride over it as a ramp. It might get completely blocked. But a lot of that has to do maybe with some of the downwind terrain, or it could even be a wraparound of wind that is channeled from one area and gotten kind of stuck and been forced to kind of wrap around, eddy around, and that could be blocking the wind of seemingly like it's created an invisible wall or an invisible hill. And of course, in some really nice situations, you can soar up the face of these invisible hills much higher than you would, then the terrain wouldn't look like it would allow. But I personally don't really believe that is the way thermal blocks are explained as a warm bubble setting up. I don't see a warm bubble holding off a cold marine. It would be dislodged by the cold air below. So I don't see it, the thermal block as it's explained. I don't see validity to that personally.
Yeah, I agree with Honza. I just want to add one thing to that. I think the conditions that I noticed coastal pilots in particular refer to as thermal blocking conditions, it's often when there's prevailing north winds as opposed to northwest, which I guess is more typical in summer. And it's because of what Honza just mentioned. So think of Muscle Rock, for example, and the upwind terrain. So fairly far upwind, we have Point Reyes, which sticks way out into the Pacific. And if you're thinking about surface winds, what it actually does is it will effectively block. Like if there's north wind, it will shield a large area fairly downwind of there, which basically includes all the area just outside of San Francisco, pretty much until what's the point south of Muscle Rock, just before Half Moon Bay? What's that? Pedro Point? Yeah. So that area will often be completely sheltered. On the days where there is this so-called thermal block, I would encourage you to look at the webcam from Sam's Chowder House in Half Moon Bay. When there is very light or zero wind at Muscle Rock, you will often see 20 to 25 knots and whitecaps in Half Moon Bay Harbor, because the wind actually, it seems to funnel in and then track along the coast, and it hits Half Moon Bay hard. So it's as if it's skipping along the coast and it's just blowing parallel to it, and it's missing certain terrain features, but then the strong wind that is actually present will actually have an effect in other places. So, yeah, it's an interesting pattern.
And north wind can be really interesting too, because you have really strong north wind in the Central Valley sometime, and you can have just out to sea really strong north winds, but then the taller mountains of the coastal range kind of block it, and there might not be like a San Francisco to Sacramento. The pressure grading could be negligible. So in the areas sort of in the bay, it can actually be fairly calm. Like Blue Rock can be fairly calm possibly, whereas it's blowing strong if you drove out into the Central Valley, and be strong north possibly on the coast. So that the north wind can be very interesting that way in the Bay Area.
Okay, I think we'll go to Bill's question or questions. He's got a lot of them. The first one I think we already answered. Which are the best models to use for free flight purposes? I think we pretty much covered that, so I'm gonna skip that. The next question is, what is the typical soarable time window after a front or rain event comes through? For Mount Tam, in my experience, it's very short, 8 to 18 hours, and threatened by low cloud base for the time following rain. How are the inland sites different? There, I've heard a 1 to 2 window, or 1 to 2 day window is applicable. I'll give this a stab first. I don't think there's necessarily a rule of thumb here. It's a function of how, I guess, how quickly the front is moving through, how cold, or I guess how well developed it is. Like if it's really a distinct closed low pressure system, if it's lingering, like how strong are the steering winds? Is it going to stay over our area? Is it going to drop out, and is high pressure going to build in afterwards? I personally don't think there's actually a distinct answer that can be given for that. I know there is this rule of thumb that there's this 2-day rule, which is basically 2 days after a cold front passes through, that's the day that you want to go flying. I think there actually is some validity to that. Like I think going into the amount of detail that Bill is asking about here, like trying to figure out where a cloud base is going to drop, it's kind of hard to do that. But with the 2-day rule, which can be, 2 days is average. It could be like a 1.5 or a 1 day rule, again, depending on how quickly things are moving out. It's generally that fine balance between when things are really unstable and wet and there's this strong wind, and things are starting to stabilize after, but you still have this cold air that makes things unstable. So somewhere between 1 to 2 days is where things get good. Honza, do you want to comment on that one?
Yeah, I would agree. It also depends on, how just generally how humid the air mass is, and this can vary different areas in the world too. It can some places, if it's a very dry air mass, then you might not necessarily get all that overdevelopment or spreading out. Sometimes in more humid areas, the day starts out good, but it quickly spreads out into like almost a stratus and blocks out all the sun. Whereas in some areas it's dry enough to sometimes even the day after the front can be good if it's dry enough already. So I think that's one of those things you kind of have to see for your area what works. And it's hard to say whether there's a perfect rule of thumb all over that applies everywhere.
Okay, anyone else? Jug.
I was going to comment on this. Could be a function of how much moisture is going out of the sky.
Yeah, I think that's true. Yeah, Jug mentioned that it's a function of how much moisture has fallen out of the sky. And I think that's true. If the ground is saturated and it's wet, cloud base is going to be low earlier. You'll just need more solar heating for it to rise. It's just another factor to consider. Like if it's wet, you might just need to wait a little bit longer for things to dry out.
It also depends on how quickly the systems are moving through too.
Yeah.
You get the next change.
Yeah, exactly. Yeah, like it's really a function of all of these parameters, like how much lingering moisture there is. Are the winds picking up? Are they going to stay light? Is it going to is it going to stagnate and then overdevelop and shade itself out? That's kind of where the forecast discussions are really useful, because it really helps give this broad picture as to how all these parameters are going to come into play. Yeah, next question.
And I would add, even though it's not necessarily on this post-frontal topic, what really, another way of thinking about thermals and convection is, we often think of you need to be heating the bottom, but if you've got cold air moving in overhead, they talk about cold air advection, cold air moving in, and if it's moving in above you and basically the top of the boundary layer is constantly being cooled, that's another way to promote convection. You either warm from the bottom or you cool from the top. So very little ground heating might be necessary if cold air is just moving, or ever colder air is moving in overhead. It's just destabilizing by the fact that the cold air is moving in overhead, and it might require almost no surface heating. And you can fly these overcast days and it's going off because it's due to cold air advection into that area. And the opposite, of course, is if warm air is moving over your area, you can have all the heating. You got very sunny blue skies, and it just, thermals aren't working. And part of that is because warm air could be sliding in overhead and just stabilizing it that way. So it's a two-way thing. It's heating from the bottom, but cooling from the top will give you great thermals. And the opposite, of course, if you shade from the bottom or warm from the top, that stabilizes things out.
All right. So like Bill, I'm interested in having difficulty in predicting the really good days at Mount Tam. And you mentioned earlier that the north wind events could have an influence on bringing in air, because I've looked for the post-frontal days, and like Bill, I see that they're, really difficult to check. But the NorCal Free Flight Film Festival showed a video of people getting extremely high. That was you. Yeah. Okay, that makes a lot of sense. Yeah, that was an incredible day, inspirational day of getting super high at Mount Tam, and so I'm trying to predict, how I can catch one of those days, and and try to parlay that into something really, really epic. So, so if you could expand on how that north wind event affects that.
Yeah. So I can comment on that day in particular because that was a really cool day. I mean, cemented in my memory for sure. So that was a cold low pressure system. That wasn't one of these offshore flow events that kind of wiped out the stable air mass. It was really cold that day. Like I was shivering, like just a couple thousand, or a few thousand feet above 5,000.
It was hailing in the bay.
It was hailing, lightning storm. Like it was really unstable that day. But that day in particular, it was a really cold late February low pressure system, and the core of the low actually passed almost directly over Mount Tam. So we kind of got these lighter winds right at the core, but like just around the periphery, there were like hailstorms. We could see it hailing out to the north. So we knew the day had the potential to get big, but I mean, like Tam it's not too big a site. Like if you need to get down, you can get down pretty quickly, land on a big beach, you'll be fine. And we just watched the day, and it was we scored it. Mike was there too.
But also the other days that we've got have been really, really cold and light east.
Yeah.
Right? And then it's just basically the reason it didn't go unstable at Tam that day is because you have the cold ocean.
Yeah.
The cold ocean kept mellowing.
So Mike was just saying that that there have been other days at Tam where it's basically been this cold, low pressure system, and then sort of light north and east winds came through, you still had that unstable profile. I think the question was more about the east and north days. I personally haven't caught one of those days. I know people have. I know Honza has. So I think I'll just turn it over to him to answer. Like how to, I guess, like maybe what wind speed aloft, or like what are the general conditions for north or easterly flow for Tam that you're looking for when you think it's going to work?
I've got, it's a very, just a one event that sticks in my mind, and it was very windy on top. I mean, must have been probably gusting offshore the night before. I would say probably close to 50, because it broke a lot of branches. I mean, there was just a lot of branch debris on the road as you drive up to the launches there, once you're on the ridge, basically once you're on the top. And so I think it was strong enough to just blow any kind of marine air well out to sea, and it just this out at sea was now this land air that was kind of starting to slosh back in. And the marine layer hadn't had a chance to really come deep underneath it. So, but I just know it was a very, very windy offshore day and night just before it, and I happened to be there just as it calmed down. So I can't give a good rule of thumb, but I know it was strong. I think it would, if you think about it, it would take a strong wind, really strong wind, to blow down the face, like east wind, or I guess a northeast wind would be offshore at Tam, because it's southwest facing, to blow all the way down 2,000 feet down Mount Tam, and actually, cause whitecaps as an offshore wind on the ocean. So it really pushed that air out. So that's just what I remember from that day.
Cool. So it's starting to get pretty late here. I know people have work and school and all kinds of things tomorrow. So maybe let's just take maximum 2 to 3 more questions and try to wrap it up. Or maybe that was the last one. I think that's it. Okay, so thank you, everyone.
Yeah, thank you, guys.
Yeah. And huge thanks to Honza for dialing in and taking time out of his business trip to be able to call in for this. It's hugely appreciated. So another round of applause for him.
Thank you. Yeah, I wish I could have been there in person with you guys
And
next
thanks
time.
to everyone who tuned in on the live stream also. So this event was recorded. I'll do some basic editing tonight or tomorrow and should have it up on YouTube pretty soon if you want to watch a replay and weren't able to catch this live. Thank you.
Thanks.
And also big thanks to Arthur, who's right back there, for